We are live. Okay, so what I'm going to do on question 13 is there's three equations. So I like to keep it organized by numbering my equation. Equation 1, equation 2, and equation 3. Okay. This could be the extra tomorrow, but I want to show you how it works, okay? So this is just a much bigger version of what we did yesterday. Instead of x, y, it's x, y, and z. Instead of an x-axis and a y-axis, you've got an x-axis, a y-axis, and a z-axis, which means you're in three-dimensional space. So if you're in 3D space, how are you going to find out where the points intersect? That'd be hard, right? 3D graph. So we definitely don't want to graph this. We want to do it by algebra. So I've got to eliminate x's, y's, and z's and find out what their answers are. So what I'm going to do is find out where three lines in space intersect. So when I look at these equations, the first thing I just noticed, and I tried to pick an easy one, was that equations 1 and equations 2, if I put these together, the x's will cancel. You guys see that? So I'm going to do that. I'm going to put a little line here. I'm going to rewrite equation 1. And equation 2. And I'm going to work with these two first together. I'm going to put a 1 here so I don't make a silly mistake, okay? So I picked 1 and 2 because I noticed that I like that because the x's will cancel, right? So I put 1 and 2 together, and I'm going to add equation 1 and equation 2 because the x's will drop out, right? The whole thing is it's still elimination. It's still elimination, okay? So then if I add these two, those are gone, right? So then I get a 6y plus a 4z equals -6. So I have another equation. That's a new equation. And this is what we did yesterday. So I'm going to call this equation 4. I'm going to call it equation 4 because what I want to do is make these problems look like what we did yesterday, okay? All right? Now, I need another equation like equation 4, so I go back up and I want to put two other equations together that cancel x. So I canceled x here. I want to do it again. I want to cancel x again. I want to cancel x again. So I'm going to put probably 2 and 3 together because I can multiply this one by 3. Put these two together, and I'll multiply this one by 3 because that'll cancel those out. So I'm going to put equation 2 and equation 3 together, but I'm not ready to add them yet because I've got to make that a 3x. So I cancel x's over here. I'm going to cancel x's over here, and then I'll make another equation that will line up with this one, okay? Okay, before I do anything with equation 2 and 3, I need to make that a 3x. Does that make sense? I need to make that a 3x so it'll cancel. So I'm going to multiply by 3. And then I'm going to rewrite equation 3 as a 3x minus a 9y plus a 12z equals, I think it's -42, I believe. And then equation 2, I'll just leave it the way it is so that I can add them. Okay, All right, here's where it's getting tricky. I don't want you to get lost. So I'm going to go through it again. Okay, I don't want you to get lost. Our goal is to eliminate, right? That's our goal, is to eliminate. Eliminated the x's, right? So that gave me an equation of y's and z's. So I need to do it again because I need another y and z equation. So I went over, and I want to eliminate the other x's on the other two equations. So then, if that was 3, they'd eliminate, right? So multiply this one by 3, 3x, negative 9y plus 4. Now, I can add them, and I'll get, and I will, I'm going to add them in a second, I'll get another equation in terms of y's and z's, which is what we did yesterday, right? I get an equation of y's and z's to be able to do what we did yesterday, okay? So once I do this next step, then it's exactly what we did yesterday, okay? So, I'm going to then add these. I'll have a negative 5y plus a 17z equals, what's that, 56, negative 56, okay? Yeah, don't let me make a dumb mistake. Where? Is that a 14?
Yeah.
And a 12? Please, though, always question what I do, because I do make mistakes. So I got a new equation 4. Let's call this equation 5. Now, if I put equation 4 and 5 together, it's what we did yesterday. You guys see that? So here's equation 4. And here's equation 5. And this is what we did yesterday. So let's get rid of the y's. I'll make that 30 and negative 30. 30 and negative 30. That's easier than these numbers. Those are big numbers. 42 and 17. So, hold on. 42 times 7. Oh, maybe. No, gotta do it this way. So I'm going to multiply this one by 5. And this one by 6, because that'll make a 30 and a negative 30. A 30 and a negative 30. Okay, this is a big problem, isn't it? You guys agree? So let me rewrite equation 4 as 30y plus a 20z equals negative 30, okay? And then equation 5 is going to be a negative 30 y plus, I don't know, that's why we use calculators, right? 17 times 6. A positive 102 z equals, these are big numbers, but that's why I have a calculator, times 6 negative 336. I'm hoping things are going to cancel out nicely for me, okay? Add these together. The y's cancel. Looks like I get 122 z equals negative 366. And hopefully that divides. 366. Please divide evenly. Please divide evenly. I get 3. Nice. That's a good number. This equals negative 3. Okay, you got one answer. Okay, now let's be smart.
Bro, one answer.
You got one answer. Okay, let's be smart. I know, we got one answer. So we got to get...
I don't think I have that. I can get for that.
Okay, we got one answer. No, we're algebra 2 now. This is not algebra 1. We're smart.
Nine, bro.
Okay, we got one answer. So how can we get y? Let's find y. What would we do?
Plug.
Now we sit. Let's put this either here or here, right? take this and plug it either here or here. Probably there, nicer numbers, right? So we plug the -3 in here, we'll get y, won't we? So I'm going to plug my -3 there. You can do this. All this is addition, subtraction, multiplication. That's all we're doing, right? You guys agree with that? All we're doing is addition, subtraction, multiplication. So now we take my -3, and I'm going to put it here, because that's a z. So I'm going to rewrite this as a 6y plus 4 times -3 equals -6. (6y minus 12 equals -6). We can do this. It's just a big problem, right? Plus 12 plus 12. 6y equals 6. Nice. Y is 1. Okay, we're getting nice numbers. Now, if we go way up to the beginning, and I know this. I know z is -3. And I know y equals 1. We could find x. Because we could plug these two values into either equation 1, or equation 2, or equation 3, and get x. I think equation 3 looks like the easiest one to plug into. How about you guys? Doesn't equation 3 look like the easiest? So now I'm going to plug -3 there, 1 there, and I'm going to have to slide this up because I'm going to run out of room, but I'll put x minus 3y. So I get my x minus 3y plus 4z equals -14. We'll put my -3 there, and I'll put my 1 there. So I'll go x minus 3 times 1 plus 4 times -3 equals -14, okay? So, x minus 3 minus 12 equals -14. X minus 15 equals -14. Plus 15 plus 15. X is equal to 1. Now, we got them. Our answer as a point in space, which we cannot graph because that'd be real hard. In space is 1, 1, -3. Wow.
That was so easy, bro.
Okay, so it's long, agreed? It's